Hi, my name is Matīss Priedīts, and I'm from TELE2 in Baltics, and today I will share our story for Snowflake journey. Who here is customer of TELE2? Okay, I can assume you can hear me quite all right. I believe that TELE2 is household name in Baltics, but not in Finland, because we don't operate in Finland. So I will tell a bit about TELE2. It is a multi-product company. We do a lot of things. We sell devices, we sell mobile network, we sell fixed network, we sell insurance. Additionally, we sell some security products. You can be free to see it in our page in internet, but pretty much a lot of things that we offer to our customers. We are operating in 4 countries, in Sweden and in Baltics, and our group headquarters are in Sweden. We are in Latvia for 24 years already, and we are by SIM cards largest telco in Latvia, although we have quite fierce competition and all other metrics with another company in Latvia. We are a lot of emphasizing on innovation. That means that right now we are spending a lot of money in order to cover 5G in Latvia. We are already 82% coverage for 5G in Latvia. That brings us really fast network, mobile network in a lot of areas in Latvia. Additionally, we are investing in new technologies to improve call quality with network and inside. That makes our lives much better. And of course, we have quite strong values with youth support. Probably some of you know Zelta Zivtiņas championship for youngsters on education. We also have strong digital responsibility, where we are creating a lot of campaigns about awareness in network, about protection and security, and so on. And that leads us to the topic about our journey in data. And what was our life before Snowflake? You must be curious about. Before Snowflake, we had quite good data stack at that time, because essentially we were on the so-called big data stack with all the good components that had before cloud and were really popular, like HDFS storage, Spark transformations, Hive and Impala for querying. And that led us to distributed data and compute on a lot of nodes, and we needed to add each year quite a few nodes. But that led us to scale amazingly, actually, in data volumes, and we could scale over petabyte of data with that infrastructure. However, scaling was not as fast as we would like to have, so it took a lot of planning in order to scale. However, with that, we had hundreds of use cases with data there, from BI, analytics, to apps, marketing solutions, self-service use cases, and it all worked, but with some limitations. So why we started to look around? As I said, scaling was quite complex in a way, because we firstly need to predict what we will need to spend on scaling. Then when we will reach some bottlenecks on scaling, we also need to predict. And if we were not lucky, we actually faced those bottlenecks before we bought new servers. And since we had to scale horizontally, that means that we always need to buy new nodes and add to cluster and predict that at right time. You can't really buy instantly new servers, especially in corporate setting, so that leads us to some bottlenecks in process in scaling. And additionally, when you buy some servers, then you can't really turn them off to save cost. They are just yours. So that's it basically. You use them until their life expires. And it led to situations where our end of month reporting was quite slow actually in a lot of settings, because we shared this cluster across Baltics. And the problem with that was that when all countries wanted to run important processes, then resource constraints started to appear because there were no country isolation. And we had to be creative how to work around that. Additionally, we had a noisy neighbor problem that one country could run some sort of workflows and let's say machine learning workflows, and essentially that created a resource problem for other countries, for other analysts, and reduced stability in the platform. Additionally, we had problems that we were quite strict when we can launch what, because for example, if we had some data problems, it was hard to run ETLs during the day when analysts are already working on data, and if it was not high priority, then it's hard to rerun it. Additionally, data governance became outdated. We didn't have a lineage, we didn't have accession history that could say what we are actually using on daily basis, what we are using monthly. So it was a bit difficult and only came out of some manual interventions. So we took a decision, and the decision was to create procurement. And procurement was to firstly start with what platform should we use. Then also it was who will be integrators, because we decided to outsource the integration. And since we decided to start with choose Snowflake as our platform, then it became clear that we also need to figure out on which cloud to put it. And we chose AWS for Snowflake, and we chose it in Sweden. Why AWS? Because typically Snowflake publish first all the things in AWS. So it's the reason why we decided AWS on Snowflake. Additionally, AWS operates in Sweden, and our group headquarters are here, and a lot of reasons from that comes to that in Sweden. Additionally, our Swedish colleagues had some good contracts with AWS already in place, so there was a lot of reasons why Sweden and AWS. I would not say that everyone in Baltics should go to Sweden, because Sweden from AWS is quite a small region, and sometimes some features in AWS firstly are in Ireland and Frankfurt before they are in Sweden. But nevertheless, that's what we decided to do, and we were up and ready after all procurements and all the demos with decision that Snowflake on AWS with external vendor will be it. We decided that we will implement Snowflake on multi-accounts, but in one region. That led us to our migration journey. In order to put some goalposts, we decided to do fixed scope, but with flexible changes in that, in order to have some sort of awareness what we will spend and how we will end project. Then the first thing that we faced, we need to ingest all the data in S3, because that's external stage. Then with batch jobs, we moved this data into Snowflake. Transformations we did with already mentioned dbt. That's where we also do tests on quality. We use dbt for that as well. In Snowflake, we had medallion architecture that you already saw in previous slides, so quite a typical solution, and we could actually reuse this slide to say how our architecture looks like. And what we also decided is to use Terraform. Terraform is infrastructure as a code tool in AWS, but not to use it in Snowflake, because Snowflake is quite simple in defining all the objects, and it's in SQL, and you really don't actually manage infrastructure yourself in Snowflake. Why Snowflake actually? This first thing, of course, we are a company with business targets, so cost was a good driver for Snowflake, and Snowflake proved to be really reasonable in their cost, which led us to discuss it further and look into that further. And what can I also mention right now, after already quite a long time in Snowflake, that cost estimates that Snowflake team provided was quite close to actual cost that we are facing right now. So it was a quite good job from their team to estimate this cost. Additionally, Snowflake architecture is something that we really enjoy as telco with really large data sets. It has this shared data architecture, which means that pretty much everyone is accessing same data. There is no need to duplicate something. Cloud does that for you. You don't need to do some replication rules and nothing. Basically, you just manage writes. Additionally, you have decoupled compute from storage. So your storage and compute is not using same resources. And also this compute, this virtual warehouse, is something that you also can split in your company as well. You can have hundreds of them if you need. And this essentially created workflow isolation. So previous problem that countries are executing something and feel that other country is doing some sort of heavy lifting, we don't know about that anymore, because countries are using different warehouses, and that's it. They don't really know what other countries are doing. Additionally, we have even virtual warehouses and for each use case, for example, for load, for transform, and for analytics. That means, let's say our ETLs failed and we need to rerun it. We rerun it with this load warehouse, and that's it basically. Analytics also doesn't feel that, except that of course they have some sort of data issue, but they don't feel that on load, because if there is some data that's fine, then they don't have any issues with that. We are running ETLs again. Additionally, there is a really good governance in Snowflake, data governance built in out of the box. First thing is that we have accession history. That is the solution where we can actually see who has used what always for each query, and that makes us realize which tables actually we use daily, which weekly, which monthly, and we can make a lot of decisions on that. That also gives us data lineage, and before we started, lineage was not part of Snowflake, although it was part of dbt. Right now we have visual lineage in Snowflake available, and that means that we can click on table and see how it comes from stage to actual lineage, and that's a really awesome solution, because essentially some companies are creating this lineage in Dravio or some tools like that manually and spending days with that, but we are just clicking on table and there it is. Additionally, we can clearly say that performance outmatch Hadoop. That's by far. It's hard to do precise POCs in all the settings we have, but that we can certainly say that Snowflake is faster. Additionally, there is a lot of more cool features that we are using, like time travel, cloning, and sharing. Time travel is that possibility we can go back in time and we can move to previous state. For example, we can, let's say you are dropping something. That's not a big problem. If you have time travel, you can undrop it, and that's it. One easy statement, and it's back there. Cloning, zero copy cloning creates different way how you can do tests, because you can clone your production table somewhere, and basically then you can test on that, and if you are successful, then you can apply changes on production. Data sharing is even better, because data sharing means that if we want to share something cross countries, cross a group, we can share in Snowflake. Cross companies, even we can share. We can go to marketplace and get some listing for data that is available and we need. Additionally, this data sharing is something how we created our development account. This is a truly great way how to have development, because we have production data shared in development account, and that means when we are developing new solutions, we are always developing them on production data. And when we are actually confident that we have completed our development, we go into production and release it. It will work absolutely fine, because we already developed it on production data without any risk on production, because we did it on dev account. There is zero infrastructure management in Snowflake for us, although there is infrastructure that we manage in AWS, so that we can get data into Snowflake. But in Snowflake as such, it's really easy, and we don't need to manage that much. In order to have even less management, we could move to some sort of SaaS solutions or something that loads data simpler into Snowflake, but that's not the way how we want to move right now. But the infrastructure management overall in platform is quite simple, I would say. Snowflake is very attractive for hiring and retention. That I can clearly say that people are not leaving company because of this migration, and we have quite a stable workforce. And of course, it always works. We have zero incidents up to date. There are no incidents for us in Snowflake. And there rarely happens some actually incidents when we talk about other customers. And if they happen, they are really minor incidents, so nothing. And it, as it stated, it updates automatically for you, so you are in control of these updates to some extent, but not that much, because you can enable them faster, disable them for some point, but it does updates automatically for you. Then, of course, there was big debate about security in cloud. And I must say that since I work both with Snowflake and AWS, then I would say that in order to move to cloud and to understand security, you need to understand shared responsibility model, because cloud and Snowflake is managing some part of security, but other part is on you. If you create poor user management and poor passwords, poor network management, then you could have problems, of course. But that's why we have quite strong security. We don't have passwords for users at all. We have identity provider for human users, that human users use identity provided from our Active Directory. So they are just logging in from their actual users, let's say, from Azure AD. Additionally, we have network rules. Even, let's say, you got some sort of credentials without corporate network, you can't get into our account at all. Of course, we have recommendations from CIS. That is a quite good standard that says what's wrong in your account, what are the security problems. It scans your account, and if there are some, then we fix them. It is really good. Of course, data encryption in transit and rest, this is a given, but absolutely necessary in order to keep data secure. It happens all over AWS and Snowflake, no problems with that. And one thing that is quite actually important to get right from the beginning in order to scale properly is roles. And role-based access control is something that we spent quite a time before we started. And we created it, I would say, right, because it's easy for us to scale. But we had a lot of warnings. If we don't do it right, that will be a mess to manage them in the future. So this is really a point that you should think about. And some big lessons learned that we can share is that when you move to Snowflake, right-size your warehouses properly from the start. If you don't know how, then start just with small warehouses in order to not create cost. For most of the use cases, small warehouses are absolutely fine. And put auto-suspend on your warehouses. That's not something we did, but if someone don't put auto-suspend, that means you turn on warehouse and it will work like on-prem, always on, but you don't need it always on. For example, analysts go home, they basically won't use overnight warehouse at all. That warehouse needs to shut down. And put auto-suspend on because you pay per second, and that's why auto-suspend is crucial. And additionally, I would say that add some resource for optimization, because wherever you are migrating from, there are some Snowflake features how you can optimize even more and how you can have it better. So think about that, whether you can reduce some technical debt that is there for previous way of working. And one really that niche thing for large data holders is that you have all this fancy time travel thing, and you have also fail-safe things from Snowflake that leads to really good management of data and disaster recovery. But sometimes you have ETL processes and you really don't need all these time travels, and to pay for them, use then transient tables that turns off these features, and that will be more cost conscious, because essentially, let's say you are like loading, deleting, let's say hourly, then you create time travel. You don't need it, because if you can reload some data hourly, then you don't need. And what's next for us? Next things are, of course, finish our migration. We have not completed that yet, but we are close to finish line. And close legacy systems. We are quite strict that we will do both, and we are green with that. In order to have some sort of order in our systems, that's absolutely necessary. Additionally, we are creating Streamlit applications. I'm not sure if you know what's Streamlit, but Streamlit essentially is a product that Snowflake acquired, and it creates you really great applications with Python. We are already creating some where we see use case for us, because it can solve a lot of your use case really easy. Also, we will go with AI model creation and have these models in place. Since we are using dbt, it's something that quite natural. We have a lot of semantic models in place, and we can reuse those. But since we are in migration, we are jumping between two systems. AI is something we won't move forward until we have some stability. Of course, we in cloud need to have FinOps culture, and that is something we are building already, but we need to continue build on that we have visibility of our costs. We have budgets on everything. We have resource monitors, resource constraints, and additionally, we know where we can optimize, where are some fruits that we can easily pick, what is more difficult, where there is not worth to optimize at all. There is some sort of technical debt, but it does not cost anything, so basically we can live with it. And we will, of course, also work there on the data governance solutions, like data classifications, all the data quality metrics, and additionally work heavy with accession and a lot of more things that Snowflake brings us. And with that, I conclude my presentation, and feel free to ask questions.
Yes, Yes, we have one from the audience, at least to the application, is related to the implementation costs. How much it is? I know it is a sensitive question, so feel free to elaborate that with regards of. Could you also state like one or two major challenges within implementation of Snowflake that TELE2 faced? And if you could share, and if you can tie that part of the cost, so that would be good. Thanks.
Yeah, that's a very sensitive question, and of course I won't disclose costs. So how to say about that? Let's say that moving to Snowflake is of course, it depends on your existing data stack. For example, for us, the challenge was to actually to realize what to scope in the project, because we had a lot of solutions but poor data governance, and that was essentially biggest challenge, because it was difficult to see whether you will need that and whether you will need that in 1 year or 2 years. So to actually exiting previous solution was bigger challenge than actually going into Snowflake. Going into Snowflake was really easy, and I don't actually foresee big challenge with going into Snowflake. So exiting previous solution, getting the agreement with vendors actually that you also need to scope it right, and what needs to be in scope and create good agreement was also quite a challenge in itself. And from my perspective, something that is really specific, but I think a lot of companies could share here, since we have quite independent countries, but we are creating solution for all of them, aligning for countries was difficult. So as you can hear, not that actually something with Snowflake or AWS, but one thing, and I can mention, it's really hard to find talent that actually has great competence both in AWS and Snowflake. So you have to be able to learn a lot before and during this project. So I would say these two things, basically learning and dealing with legacy was, and on cost, nothing specific, but it is big project. You can't do it migration for free.
Good.
Did you exceed the budget?
Sorry?
Did you exceed the budget?
No, we're under it.
That's it.
And in the timeline, any aspirations regarding AI implementation, following up the Tuomo presentation leading up to you? Any aspirations in TELE2 to engage with AI models that are in Snowflake?
Definitely. I think Q4 this year, we already will create some pilots on AI and see how actually they perform, and can we get some sort of really standardized models that are easy to query, where there are really stable models. Can we actually create some sort of production questions that we are confident that it can answer, and to demand that do not hallucinate on everything else.
Great. Yeah, please.
Yeah, so just a quick question. So you said you had like petabytes of data volume on HDFS. So how much of that you are now operating within the Snowflake? So did you migrate it all or some part of? And that's one. And second, how long it took, like in the timeline, to do the migration?
Okay. So first question regarding actual terabyte comparison. So thing is that how HDFS works, a bit I need to go into this technical area. HDFS, in order to assure that your data is safe, are creating replication. So recommended replication is free. So let's say each thing that you store in HDFS, you replicate over 3 servers in order to get safety that it will work. And that is something that is included in your storage. Additionally, you can have additionally backups for that data, so you have a lot of replications. That's why it is terabytes and petabytes are there. So we are not charged for replication in cloud. So in cloud, if for example we move 20 terabytes, then it's 20 terabytes. In HDFS we have 20 terabytes critical data. It could be 100 terabytes because of replication. That means that it's not one-to-one to compare. Additionally, when you actually are moving in Snowflake, Snowflake has quite good compression. So additionally, it compresses the data. 20 terabytes in S3 is not 20 terabytes in Snowflake S3. That leads to approximately we are keeping around 10 to 15% of data volumes that we had before right now. We are not migrating everything. As I said, we are cutting some things off and we are just migrating essentially what we need. So it could be that something we are skipping, but biggest data volumes are created by things that we need. So I could say that around 20% should be maximum that we will have from data volume from one to another. Did I answer regarding the sizing? And yeah. So
the second was timeline-wise, so how much time?
Timeline-wise, it was rather difficult because for each source we need to repoint ETLs to AWS, and that was not actually difficult to implement, but it was difficult internally to communicate because we chose in order to each source to ingest to S3, and that led to quite big time frame to get actually teams in order to create service users, etc. Everything created and network policies created and so on, so we can actually repoint. Moving actual data, like historical data or that's really simple. That we can do in hours with appropriate warehouse. It's also something where we created huge warehouses in order for that to perform fast. There's a lot of parallelism, so it happens fast, and we just really fastly move history around. So there are two parts into how fast you can do. First part is that it depends on your internal organization how fast you can do migration. That is something really organizational-wise, how you can repoint all ETLs. But to move historical data, that we could have done in, let's say, I don't know, 2 days. But if we already know what we need to migrate, because that's easy. We have procedures in place, we know how to do them. Snowflake has big warehouse all for us. We can do it really quickly. So we could do it really fast if we wanted to.
So it's still like some terabytes into the servers.
We can load terabytes under hour with big warehouse enough.
And one more follow-up is regarding the iceberg open tables format. Are you planning to use them?
Regarding iceberg tables, it's something that we plan to investigate, but we don't actually plan to use them because my opinion that you need iceberg tables more if you consider living solution. We don't consider living solution right now.
That's good then. All right, guys. Anything else? Or we can say thanks, Matīss.